Hello, Algebra 1. Today we are going to continue talking about linear programming. So let's go ahead and talk about some things we need to remember. First of all, the feasible region is where your solution set is. This is the darkest part of your graph. Our mins and maxes are always found at the vertices, which is another word for corners of that feasible region. And we should give our answers using complete sentences. Now, your teacher might not care so much about that last one, so you should confirm with them. All right, so first thing we're going to do is write and graph a system of inequalities based on the information below. You work for your uncle's company over spring break to earn some spending money. You spend your time working on 2 different tasks, answering phones and sending faxes. You are able to work at least 10 hours that week. You earn $20 for answering phones and $10 for sending faxes. The company says they can pay you at most $200. And we're going to let X represent the number of hours spent answering phone and let Y represent the number of hours sending faxes. So to start off, I have my totals are 10. It says at least 10, so that's a greater than or equal to, and 200 at most, so that's a less than or equal to. 200 is my money, so I know that the 20 and the 10 need to go in that inequality. So it's 20 for answering phones, and that's going to be X, and then 10 for sending faxes. And then finally, I know that X plus Y has to be greater than or equal to 10 because that's the number of hours I can work. Next thing I'm going to do is label down here at the bottom. They told me X is the number of hours on the phone and Y is the number of hours faxing. I should also put a title, so I'm just going to call this spring break job. All right, so now in order to graph this, what I need to go ahead and do is either solve for Y or I can find the X and Y intercepts using a method we learned back in first semester. But I think most people are going to choose to solve for Y, so we'll go ahead, we'll subtract our X over. That means our Y intercept is up at 10, and we have a slope of -1. Okay, and this is a solid line. And this is a greater than, so I will be shading up. Now I need to solve for Y for my other inequality, so I'm going to subtract that 20x over and divide by 10. That's a -2x plus 20. All right, so now I'm going to graph that one. I'm up at 20, down to right 1. Okay, and that's going to be solid as well. And that is a less than, so I'm going to shade below. And so our feasible region is where they overlap, which is going to be this green triangle in the middle. So I'm just going to color that in a little more. Okay, it should be this triangle in the middle. And there you go. All right, so now we're going to put it all together. We are going to graph, and we are going to answer questions as well. The head of the indoor pool you work at is organizing the schedule for next week. You can work at most 18 hours, and since you have a set amount you can earn each month, you can be paid only $2.10 or less. You earn $10 an hour for acting as a cashier at the food stand and $15 an hour for being a lifeguard. Let X represent the number of hours working as a cashier. Okay, I'm going to put that down here. All right, that's my x-axis. And let Y represent the number of hours as a lifeguard. Notice your inequalities were already written for you and they solved for Y. How nice. But we have a couple other things I want to do before we graph. We do need a title, so I'm going to call this pool job. And also I think it's helpful to put how much money you're making for each job on the axis. So our cashier was $10 because we'll use that in a little bit, and the lifeguard was $15. All right, now let's go ahead and graph. Y-intercept up at 18, slope of -1, so down 1 over 1. Okay, so that's just this inequality right here, and that's a less than. Oh, first I have to draw my line. It's going to be solid because I have that equal to, and it's a less than, so I'm shading below. Now I'm going to graph the next one, y-intercept at 14, and down to right 3. Okay, and then you kind of run out of room. Okay, now we do hit that other line, so I'm going to circle that. That's going to be one of our vertices. Okay, and then this is also a less than, so I'm shading below that line, all the way below. And it should be this kind of like orangey red part. Okay, I'll color that in a little more. Okay, so we have several different vertices. We have this one that we circled. That's where the lines hit. That's at the point 12, 6. And again, 12 is cashier and 6 is the lifeguard. We also have this vertex right here, this corner. That's going to be 18, 0. And again, this is cashier. This is lifeguard. And then we also have this corner up here. This is 0, 14, again, cashier, lifeguard. Technically, you have 0, 0 as well, but this means you didn't work any hours, and so we're just going to kind of ignore that. All right, so now under these conditions, can you work as a cashier for 2 hours and a lifeguard for 12? So cashier 2, lifeguard 12, and yeah, that is in my feasible region. So yes. And we know because 212 is in the feasible region. All right, now how much money would you earn if you worked as a cashier for 2 hours and a lifeguard for 12? All right, so 2 hours as a cashier, and again, we already worked down cashiers make $10, and a lifeguard, 12 hours we're working, lifeguards make 15. So we'll just go ahead and type this in. I think it's 12 times 15 is 180 maybe? Yep, so 180 plus 20, that's going to be $200. Okay. All right, so now what is the maximum amount of money you could earn if you decide to only work as a cashier? So if we're only working as a cashier, we're going to go ahead, we're going to look at our vertex that's only a cashier. That's this guy right here. So that's this point, 18, 0. That's 18 hours as a lifeguard, or excuse me, as a cashier. And I know I make $10 an hour. So that's going to be $180. I make $180. So now if I only work as a lifeguard, okay, here's the lifeguard. This is the point 0, 14. Okay, again, this is cashier lifeguard. So that's 14 hours as the lifeguard. And again, the lifeguard got $15 an hour. So that's $210, which you can see is more. Then if you work as both a cashier and a lifeguard, that vertex would be this one right here, 12, 6. Cashier, lifeguard. So again, 12 hours as a cashier and we are making $10 an hour. 6 hours as a lifeguard and we're making $15 an hour. And then this is a 120. 15 times 6 is 90. So this is $210. Okay, and there you go. So you can see it is in your best interest to either work as a lifeguard or both a cashier and lifeguard, not just a cashier. All right, let's try one more. You go to the store to buy some new pairs of socks. You want to buy at least 5 pairs. Red socks cost $4 per pair and striped socks cost $5 per pair. You only have $30 in your pocket. Let X represent the number of red pairs of socks and let Y represent the number of pairs of striped socks. So let's go ahead and label our axes. X is the number of red pairs. And then I'm also just going to say red pairs were $4. And Y is the number of striped pairs. And again, striped were $5. And this is going to be my title, socks. And we were given our inequality, so now we're just going to go ahead and graph. Y-intercept up at 5, slope of -1. Solid line because I have the equal to. It is a greater than, so we are shading up, which is this whole part up here. Okay, we'll graph our second line, y-intercept at 6, down 4, right 5. 1, 2, 3, 4, 1, 2, 3, 4, 5. Okay, and then that's all you can get, so it's just kind of going to be like that. That one's a less than, so we are shading below. All right, so I like to label my vertices. This one we don't really know what it is. I'm going to call it like a 7.5 for right now. It's something like that. This one is a 5, 0. Okay, and again, this is red pairs and then striped pairs. This is a 0, 6. Again, red, striped, and a 0, 5. So again, these are just the corners of that blue region, which is the feasible region. Under these conditions, could you buy 4 pairs of red socks and 1 pair of striped socks? All right, let's find out. 4, 1. Yeah, that's actually right on the line, but since the line is solid, yes, we can. I'll say 4, 1 is on a solid line. You could also say it's part of the feasible region. You decide to only buy striped socks. What is the maximum amount of money you will spend? Okay, so let's find our striped socks. That's on our y-axis, so our options are 5 striped socks or 6 striped socks. They're asking for a maximum, so that means I want the bigger one, 0, 6. So I have 6 pairs of striped socks, and again, I wrote down they were $5 each, so this is going to be $30. And this is how many pairs, and we already said that's 6. So 6 pairs for $30. You decide to only buy red socks. What is the minimum amount of money you will spend? Okay, so minimum means least. Look at your red pairs. We have the 7.5. We're not really sure what it is. And we have 5, 0. Well, but since it's minimum, we want the smaller one, so we're going to go with 5, 0. And again, red pairs are only $4. So this is 5 times 4. That's going to be $20. So this is 5 pairs for $20. Okay, and then finally, why do we only need quadrant 1 of this graph? This guy right here. So the main reason is because this is a real life situation. We're dealing with number of socks, and we can't have a negative number of socks. So we are always going to be in quadrant 1 for these types of problems. Okay, have yourself a great day. Bye.